Hey everyone, welcome to the Tom's Hardware, Jared and Paul CPU show. So it's mostly going to be Paul today. Paul, how you doing?
Pretty good. Pretty
I was
good.
off last week. I'm going to be off next week as well. Sorry, that's the breaks. Anyway, we are going to talk about mostly CPUs today. We'll talk a little bit about graphics cards. We also want to hit the exciting news of the week. You ready? Shall we jump into the news?
Let's jump right into the news. So we'll have our little face off.
Yes. Takes on the news. SMIC, US wants to prevent SMIC and China from making 14 nanometer chips now. It already has tried to block 10 nanometer technologies, extreme ultraviolet stuff. So now it's trying to block the 14 nanometer stuff, the 14 nanometer tools. Paul, don't they already have the 14 nanometer stuff up and running? Like,
Okay,
can we
so
block them?
here's the problem. Okay, so the United States has blocked them from using EUV. We've already done this. Block China from using EUV tools. Those tools can print down to a very small size. Now, somebody finally told the United States government that you can use DUV, which is the existing tech, and do multi-patterning, which is where you do multiple exposures of the same layer and you can get the same size as EUV. It's just a lot harder, and it's not as friendly economically. Your yield goes to trash if you're doing like quad patterning, but you can get down to below 14 nanometer. You can get to 7 or 5 with DUV. You're just not going to make as much money doing it. Obviously, the Chinese government really doesn't care about making a whole lot of money using from these chips. So we've got wise to the fact that they're using them this way and just taking the loss on the profit. And now we're saying, okay, no DUV either. I don't think it's going to work.
But they already have those tools, right?
They already have those tools. What they're actually trying to do is tell them, hey,
Stop.
You have to register each tool with the United States government and tell us what size of chip that you're using it to make. And we should be able to investigate and see if you want to have those machines. You have to let us verify. So it's almost like when they inspect for nuclear weapons in North Korea or Iran, when they've done this in the past. They're expecting China to do this. It's not going to happen.
Tools of mass production.
They got duped and they realized it. So that's the story.
All right. Oops, wrong one. James Webb Space Telescope. Now this is probably my favorite of the images so far. We've got like 20 years of images incoming. The cool thing about this, or the fun part of this story, is the storage for the James Webb Space Telescope consists of a 68 gigabyte SSD. And it basically can fill it up in a matter of a couple of hours in an extreme scenario where it's snapping pictures as fast as it can. It takes like a day to offload the data through radio back to the Earth. So kind of fun. What do we know about the SSD, Paul?
Well, when I first heard this news, it reminded me of when they imaged the black hole. Back in 2017, I had to Google, it was so far back, but I did recall there were some really crazy storage requirements. In order to see the black hole, they had to have 5 petabytes of hard drives and in order to record it. And they put them on a truck and they had to ship them. It was over 1,000 pounds of hard drives. It was so much data that they couldn't just transmit it from the space, the area where they received it to the researchers. They had to put it on a truck because it would take too long to send 5 petabytes. So when they did it, somebody worked out the math. By moving it via truck, they passed data at 14 gigabytes a second. Now, that was with the telescope 5 years ago. So when I seen that these images are astounding and mind-blowing, and surely they would consume far more data. Now, they probably had to have made some kind of breakthrough in data storage or the manner in which they transmit this data, or compression or something, because now they're doing it in 64 gigabyte chunks is the max that the telescope can store. It's if you get a chance, they've posted some information on it for you storage nerds. It's really cool stuff. And read our article.
Yes. All right, next up, I skipped ahead. TSMC. There are reports. I don't think TSMC is saying this, but there are reports via TrendForce saying that TSMC and Samsung, and other chip foundries are facing a wave of order cancellations, or at least AMD, Nvidia, Intel, whoever. They're trying to back out because the shortages are over, crypto mining is gone away, no one's wanting to make chips. Not no one, but how bad is it?
Right now, what you're seeing is the initial waves of people backing off on, the larger processes. The problem is TSMC was making folks prepay for wafers. So what these companies are trying to do right now is they're trying to shift their wafer allocation. So, for instance, AMD, or let's say NVIDIA. NVIDIA says, we already paid for 50,000 wafers a month, and the money's already in TSMC's bank account. So we can't cancel. So they have 50,000 wafers a month. What are they going to do? Well, because during the shortage, what they would do is they would just make high-end products more than anything. 3080, 3090, because people are forced to buy literally whatever they can get. So they shift all of their production to these really high-end models where they make the most money. Now what you're going to see is them take these wafer allocations. They say, okay, we got 50,000 wafers, and everybody's broke because of inflation. And the economy's bad, and there's no more crypto. So we need to start selling some more reasonably priced video cards and stuff like that. So first things first, they're going to shift to moving more towards the mainstream and lower end products in order to eat up that wafer allocation. As those wafer prepays expire, you're going to see them start to draw back. This is both good and bad, because it means that there's going to be a flood of products on the market in certain things right when a flood of used stuff is coming in. And this could lead people to prolong new product launches, to say, hey, let's wait a month or two. We got to sell this old stuff, and when we can actually make some money. So
yeah, there's already debate of like, has NVIDIA, like Absolutely. They never announced a release date for ADA, but at this point, everyone's going, are you guys pushing that back just to clear out Ampere? And our guess is yes.
Yeah, and I mean, just think about the night and day difference. Just a few months ago, we're talking about, what was it, a 2080 with 12 gigabytes? Was that it? Or
3080.
30. What? No. They released previous gen cards.
Oh.
They re-released them with more memory, not for miners.
2060 12 gig, that's right.
Yeah. So, excuse me, I forget exactly which model. But, they were releasing prior gen cards. I mean, what a difference a few months made.
Yeah, and I mean, we just got through Prime Day this past couple of days. There's probably still sales ongoing. It's the only thing I'm going to say about Prime Day, I promise. But what I found interesting is the 3090 and the 3090 Ti got slashed hard, and the 3080. Like, there was a 3080 12 gigabyte, which is pretty dang close to 3080 Ti in performance. Like, I would say within 5% for sure. And it was on sale with an instant rebate, so like no mail-in rebate stuff, for $730 at Newegg. The 3090s, they were multiple cards at both Newegg and Amazon for $12.99. And the 3090 Ti, multiple cards at Newegg and Amazon for $14.99. Like, just gone is that $1,500 to $2,000 price range that we were seeing on those same cards as little as a month ago. And, I can't say that I feel bad about that, because the 3080 12 gigabyte probably was supposed to be an $800 product at launch. And then crypto happened. All right. Wrapping up we got a couple more here. This one's awesome.
Yeah, it's so stupid. It's great, but it's functional.
Right. This is an M.2 to SATA adapter, capable of handling 5 SATA SSDs or drives. You still got to provide power. This is from SilverStone, as you can see. The interesting thing to me, like, it's actually only a 2-lane PCI Express Gen 3 connection.
Oh, is it only 2? Okay.
Yeah, and I kind of thought, I'm like, come on, you've got 5 ports. They could have stuck a 6th port on there, and if they'd done a 4-lane, then there would have been 0 bottleneck potential, because the SATA ports max out at, well, they say 6 gigabits per second, but that's 8-bit, 10-bit encoding, so you only get 80% of that, which works out to, that's where we get the whole maximum throughput of 600 megabytes per second. Anyway, real world throughput, maybe 550 megabytes per second, times 5, that's 25, 26, 2700 megabytes per second. 2 lanes can't do that. 4 lanes could have done that and more. But anyway, it's still, I guess, what's your use case for this, Paul?
Well, if you're mining Chia, you would probably find it very hard to find a motherboard with more than like 6 or 8 SATA ports. I mean, so I'm told. There's been a whole cottage market of adapters for these things, for these folks who are doing, storage-based mining and using SATA cards. Now, as we were talking about, that wouldn't be so great if your M.2 slot is the only one is underneath your GPU. That would be interesting to get the cords around there. But there are 90-degree adapters. I could work around it maybe. I think it's interesting. I commented to Jared when we first saw this. What's with the heat sink? Come on. I mean, the maximum power that you could put through an M.2 according to spec, I believe, is 5.4 watts. But, SSDs have them too. But that's more for the controller than anything. But, they got a little switch in there, obviously. In order to split it, and it's got to, translate from SATA to whatever. I think it's cool. It's one of those things that I'm glad it exists, because I like to see little things like this. It's weird. It's cool. I like it. I want one, but I probably wouldn't buy it.
So you mentioned Chia, and we talked about this a lot more last year. Chia's like plummeted like everything else. Chia was in the hundreds of dollars. It's now at like $40. If you had an 8 terabyte hard drive devoted to Chia, sitting there filled with Chia plots, that can take, that's a lot of wear and tear on your SSD to create 8 terabytes of plots as well. Currently, that will make you something around $3.50 a month, give or take. Good old Chia.
You got some old drives.
Then you can probably cause them to fail. Yes. All right, last one, and this one's great. Bitmain, Antminer E9 ASIC. Now,
touchdown.
Yes, talk about too little, too late. They originally were shooting for like 3,000 something megahash per second and more power. But 2,400 megahash per second, 1920 watts. It's 0.8 watts per megahash, so that's basically double what an RTX 3080 or 3090 does, which that sounds good, but for an ASIC that only does Ethereum mining, that does not impress me much at all.
And therein lies the rub, my friend.
Double the efficiency. $10,000. $40 per day estimated profits, 250 days to break even on your investment. But crypto prices have been going down. We don't know where they'll go next. They could go back. The bigger thing is it's kind of penciled in. Maybe it's even written in pen now. Ethereum's supposed to dump proof of work mining. And when that happens, which is slated tentatively for August, maybe September, if it actually happens, then this becomes far less useful. You could still do Ethereum Classic. You could do other Dagger Hashimoto-based algorithms. But the profits from those are going to be way lower than Ethereum. So anyway, my thing is, isn't it suspect that Bitmain, now that Ethereum mining profits are in the toilet, that they finally got these available for other people to purchase? Tell me they haven't been mining on them for months or...
Yeah, I got to agree. Bitmain's probably got a whole factories full of these. And they're looking at these shelves upon shelves of stuff, and they're like, man, we need to do something with these because the rain is coming. One thing that's terrible about Bitmain and a lot of these silicon providers is they will base the pricing actually on... They'll adjust. The 9,999... is their funny money, but they adjust it daily based upon valuations, because they want you to have a certain payoff date of 250. So I'm curious if they're doing that with this, because that would really probably not work in their favor right now. Normally it does work in their favor to adjust the prices, but when Intel recently started making ASICs, that's one of their big value props is we'll charge you the same price no matter what. The crypto guys like Bitmain, they will base it on current crypto valuations. So I would be interested to know if they're actually doing that, because I think that might hurt them if Ethereum went back up. Anyway, it's basically a pile of tin once Ethereum goes proof of stake. I mean, like Jared so rightly pointed out, there are some things to use it for, but they
If you
ain't
took
worth
all
it.
of the GPU mining power that's in, well, not, let's just say it's all GPU. It's probably not, but all the mining power currently dedicated to Ethereum. Ethereum goes proof of stake, and that all disappears. Right now, like 97%, 98% of all GPU mining potential is going into Ethereum. Like all these other coins combined, and there are hundreds of them, and a lot of them are worthless, but whatever. All of them combined make nothing. They can't handle a 50-fold increase in hash rate. Like it just tanked the value of the coin and the profitability of mining. So like right now, if you look, and there's probably something like Octopus or whatever, where people are like, hey, I could still make $1 a day on a 3080 mining Octopus. That's only like 20% less than Ethereum. But if everyone tries to go to Octopus, it will just collapse. Anyway, not sorry. Bitmain, that's a shady thing. And that $9.99, $99.99, $10,000 does not include shipping and customs and all the other crap you'd have to pay for. So, really great stuff. Go away, cryptocurrency.
And that's another thing. Another point that a lot of people miss, and another Intel value prop, is crypto miners are subject to tariff when they come from Bitmain. And so you're going to pay even more.
Yeah.
I think they work it into the price, but that's something else. Intel's like, hey, we charge the same no matter what, and no tariffs.
Yeah. All right, that does it for our news of the week. Lots of other stuff to talk about today. GPU prices we talked a little bit about. They haven't fallen as much as we would have hoped, but they're coming down. But looking forward to the fall. Like we have a good old showcase Showdown, Bob Barker channeling. He's probably dead, but anyway. We've got AMD versus NVIDIA on the GPU side, AMD versus Intel on the CPU side. We're going to talk about CPUs for the rest of this. Shall we jump right into it?
Yeah.
You want to give us any preface, or should I pull up your slide?
The
slide that I made for you.
Raptor Lake, and basically what we're looking at is there is an epic showdown coming. You've got Raptor Lake from Intel, which is second gen Alder Lake. Alder Lake has essentially the second generation of Alder Lake, a refresh, but with some additions. And Alder Lake has done very well and has unseated AMD from their position of dominance. So Zen 3 is now, as Intel's CEO has famously said, in the rear view as far as performance goes. But AMD, of course, is not sitting still. They have Zen 4, an entirely new architecture. And
all right,
looks promising. We'll see.
So this is, we've got a couple of different looks at specs. This is kind of the quick high-level overview showing Alder Lake and Raptor Lake. Main thing being they're going to 16 E cores. They're Gracemont energy efficient cores. Base and boost clock speeds aren't really known. Memory speed, it looks like it might be going up to 5600 megahertz or whatever mega transfers per second, or 5200 on the DDR5. DDR4 stays at 3200. And clock speeds, we're hearing rumors of the P cores hitting 5.8 gigahertz.
Correct. Now, there was a submission from Geekbench just 2 days ago where it was seen hitting 5.7 on a K model of the 13900K. The submission's kind of contested because, Geekbench actually pulled the submission, but it looks plenty real. And it lines up well with the claims that the KS will be 5.8 plus. And that sounds pretty plausible.
All right, so other things like Raptor Lake's in the wild now. Like people definitely have them. One sold on some secondhand market. It wasn't eBay, right? But people have sold Raptor Lake chips and bought them with the right motherboard and BIOS and stuff, you can run them. Anyway, benchmarks are coming out. So here, someone posted some benchmark results comparing the i9 12900KF to the 13900K. We just wrote about those today. You can see, 9% improvement in single-threaded on Cinebench, 10% on Geekbench, 14% on Cinebench R23. Sorry, I said Cinebench before. It was CPU Zbench. All right. So single thread's getting a little bit better, but then look at the multi-threaded benchmarks. CPU Bench N-Thread, 46%, Geekbench, 23%, Cinebench, 39%. And then you got
those
3D.
Those E-cores ain't no joke. I mean,
Yeah.
when
There's a lot of them.
Yeah, they added a lot more E-cores, and the big thing about the E-cores when they say efficiency isn't so much about power efficiency. If you actually look at, if people always mistake that. Intel's documentation is clear. They clear as mud, but what they're really referring to is area efficiency. You could fit 4 of them in the size of one big core. So you can just spam them. I mean, they're just copy pasting these E-cores, and to great effect. When you look at this, you have to realize you typically don't see these kind of increases unless you're power constrained. If which we'll talk about in a second, was Zen 4, but you typically don't see these kind of increases unless you're power constrained in the same package, right? Yes, you'll see jumps like this as you go from chip generation to chip generation, but for a very lightly modified die and package, it's still socket compatible. That's pretty awesome. That's pretty good.
So if you look at, I guess, Raptor Lake now, or Alder Lake. So Alder Lake had basically 10 blocks, if you want to call them, for CPU cores. Yep. 8 of them were P cores, 2 of them were E cores. So you ended up with 8 of each. Raptor Lake bumps that up. You've now got 12 blocks, and so you've got 16 E cores and 12 and 8 P cores. Do they have a product in the works? I thought I heard about this. Maybe you got the name, where they just do all E cores. Like, obviously that's more server stuff, not
they
not
do
like
it.
The home user.
It's right on the edge of my tongue. It is Emerald Rapids. Emerald Rapids. No, wait. Emerald is second.
That's Sapphire Rapids.
It's coming. It's Granite Rapids, I believe.
Yeah.
I would have to double check. It's an entirely different roadmap, but it's not out yet. We haven't seen any leaked things, but it's all E cores. And there's a really big reason why. A lot of the big thing about the E cores is that really helps them deal with ARM. ARM does the big core, little core, and with ARM chips, they're really moving to make these ARM chips with basically all E cores for servers. So it's kind of a whole different segment, but there's a big reason why. And if you follow servers, you know that Ampere is making a lot of inroads, and that's because they're using this technique today. But it's just, there are no P cores. They're all E cores, low clocked, very, very efficient cores.
So if we were talking just like in the same size as your current Raptor Lake chips will be, the upcoming, Intel could do 96 E cores instead of
Absolutely.
96 cores and threads instead of 24 cores and 32 threads.
They could do it with a minimum of effort. Like we mentioned, it's just blocks, right?
And that's on a we expect Raptor Lake's going to be relatively small. It'll be probably 150 to 200 millimeters square on die size. And it's got a lot of stuff in there that a server doesn't necessarily need, like graphics. And anyway, Intel could take, instead of doing 12 CPU blocks with 4 cores each on the E cores, actually I said 96, it would be 48. But they could easily go up to hey, what if we do 16 of those and get 64 E cores? Or we could do maybe even 32. I mean, I don't know how big they could go, but we could end up with some Granite Rapids, whatever it's called, that have a lot of cores. It'll be interesting to see where that goes.
Modern server chips, I don't have a server chip handy, but they're about 4 times as big as this, which is your standard.
Let me show you full screen there.
12900K basically.
There you go.
I mean, they're about 4 times the area of this, roughly 3.5 to 4 times. You could cram in a whole lot of cores if it's all E core. I wish I had a server chip handy.
Yeah, they're all in use.
Just in the other room.
All right. Let's talk about how this is going to stack up to AMD. We've got Raptor
That's
Lake
the
coming
$1 million
soon.
question. Yeah.
Here's the tentative. I filled in the question mark stuff. Paul kind of vetted it. Errors are mine. This is sort of where we expect the top consumer Zen 4 to land. You know, give or take 10% maybe. I don't know. We don't know actual real world performance because it's more than just clock speeds and core counts. Cache size on the L1 cache, I doubt it will change because we've been kind of sitting at that 32 kilobyte L1 cache size for a long time, but it could. L3 caches might change. We do know that Zen 4 adds AVX 512, which is funny because Alder Lake and Raptor Lake have it but don't have it. And then bigger L2 caches in Zen 4. They're 1 megabyte instead of 512K. Overall, though, like most likely we're going to be looking at a 16 core, 2 chiplet, plus I guess 3 chiplet, because you'll have the IO chiplet plus the 2 compute chiplets, CPU chiplets. 32 threads, same as we've got already with Zen 3, but they'll be clocked maybe 10 to 15% higher, and they will have IPC boost. We're thinking 10 to 15%, right?
No. 8 to 10. That's
IPC.
from AMD.
So 10% at most IPC if we're
Yes.
generous.
Oh, that's from AMD.
But if you combine those 10% plus potentially 15% higher clocks, that's still a big increase. And then the important thing here is look at the power line. You can see Zen 3, the 5950X, is a 105 base power. It can go up to its peak power of 142 watts. They're cranking that all the way up to 170 watt as a socket power it can supply 230 watts for limited time, right?
Yeah, and here's an important distinction. AMD has been bandying about a 40% increase in overall performance. And when they're talking about that, they're talking about multi-threaded workloads. But the reason why is pretty simple. If you have a 5950X, which is 16 cores, when you load the chip, it will reach a point where it can't go faster. It's when about 10 to 12, you can plot it, when it's about 10 to 12 cores is when it reaches the functional power limit of the socket. So those extra 4 cores really aren't doing much for you. What happens is it drops the power of all of the individual cores in order to power those 4 cores, and the scaling is atrocious for actual performance in multi-threaded workloads. So
yeah, and that's why the 5900X is actually faster for gaming than the 5950.
Yes, exactly, yes, because it's at that sweet spot. So by increasing the power limits, what they're doing is instead of, as you load cores, 1 core, 2 core, 4 core, 8 core, 12, bam, you're at a thing. You'll go boom all the way up to 16. You'll have a nice curve. You get a more linear increase in performance because they have the ability to deliver more power. But the only thing about that is, what is that going to fix? It's going to fix the 16 core. But the 12 core wasn't power constrained. So you're not going to see a 40% increase in the 12 core or the 8 core in multi-threaded workload on a like-for-like basis. You're just not. The IPC doesn't work out to that. So we'll have to, there's always a little bit of marketing. And, when we look at Intel with their more E-cores is the same thing. Those additional E-cores are on the highest end model. Now, we're assuming they'll have more E-cores on 12700K. If they do, that's great. That's a real advance. And then right now the i5s, the K model has E-cores, but any non-K i5 doesn't have E-cores. If they add E-cores to the non-K i5s, which I'm told that's going to happen, man, imagine a 12400 with E-cores. If you're into chips, you would know that's a spectacular value even without E-cores. With E-cores, it'd be great. Anyway, the point is the highest end chips on AMD are going to be the ones that benefit. But the mid-range chips, not so much. It'll be
How many different designs does Intel have right now for Alder Lake? Meaning physical 3 dies. So you've got one that's
2 dies off the top of my head.
You've got one that has 6 P cores, no E cores. Is that right?
Correct. Yes, and that's what they're using for the 12400 and below. But they'll use a mix. When you buy a 12400, which is a 6-core, just 6P cores, no E cores, you can get one of two dies. You could either get the 6-core die that has no E cores, period, or you could get a harvested defective die where the E cores just didn't work. So it actually has them physically, but they're not there. Intel came up with the technique to where this no longer hurts performance. It used to be when you disabled dies, it could cause a real problems with your fabric, because next to each core you have a chunk of L3 cache, and it's shared among all the cores, and it's on a ring stop. So when the chip is communicating, it communicates in a circle and hits each stop. It used to be when they disabled a core, they disabled the L3 with it, right? And that ring stop would die, and so it costs you performance. But they changed that. Now they don't ever disable any full L3 slice. They just reduce the capacity of each slice.
Just to market segmentation, right?
Yeah, it's very smart. Anyway, getting in the weeds. Point is, yeah, you can get one and two.
All right. Any questions anyone has about Raptor Lake and Zen 4 so far? Throw them in chat. We're watching it. I don't really see anything. People joking about thermal take power supplies. I think that was for the SilverStone adapter.
Yeah.
Now they got AVX 512 working. I'm not sure, Daryl, if you're talking about on Alder Lake or Raptor Lake. Like, they had it working if you disabled your E cores, but that's the key. Is like, you don't buy the high-end chips and then disable the E cores.
Well,
it would be interesting if like the i5 chips had their AVX 512 enabled, but I don't think Intel's going to be that generous.
Yeah, Intel, in the first revisions, you could disable the E cores and AVX 512 would work, but in later revisions of the chip, they actually fused it off. In the silicon, they lasered it, as they say. Really, what they do when we call it that, lasered, is they just pop a little fuse in there, but it's the same thing. It might as well not exist.
So, is there a chance for Intel at some point to have heterogeneous architecture like they've got, where the E cores don't have AVX 512, but they still enable AVX 512 support?
Mm-hmm.
Like, that's just an operating system thing, right?
It is, and there's a ton of complexity involved there. And the problem is if you send the wrong instruction to the wrong core, you're going to get a bloop, BSOD. I mean, it's not it's not something that the chip can recover from gracefully, or the operating system rather, at least not to my knowledge. It's a real problem to where if there's even just one mistake in the scheduling, so then you get to the point to where the scheduling becomes absolutely super complex, and they can't really do it with, they can do it with that granularity, but then you're starting to have overhead.
Yeah, the overhead goes up a lot and you're scheduling. Like, I actually studied computer science, and back in the day we were running on a 386 or 486, or maybe it was a Pentium. But the point being, like, your scheduling slice, like, imagine you're trying to break your processor window up into 1,000 slices. Give each chip 1 millisecond, or each app slice is a 1 millisecond increment. Like, that can go really fast if your scheduling gets too complex. And so, you don't want to use any more of that time slice than necessary on scheduling, so you have to keep it simple. Stupid.
Yeah, and you also run into just what's called the observer effect. So if you're running so for instance, when I'm testing games, or testing anything, if you increase the granularity enough to where you're taking measurements so fast, just by watching and observing what's going on very granularly, you create a workload of your own. It then is, now you're literally using a whole core or multiple cores. I've seen it with SSDs. You can use almost an entire Xeon, like 18 cores back in the day, just from IO requests, not the actual work. So if you're getting that granular with your scheduling, and you're trying to do it in an automated fashion, because this stuff is encoded that way, so you have to start watching it, and you have to say, oh, that one needs to go here, because it's not sent there. You have to make it go there. Then it falls apart. It's going to be very, very compute intensive. You have to add a few more cores just for that.
Yeah, you wonder if you could have like the E-cores not support AVX 512, but have enough smarts to fail
Bounce it.
gracefully and bounce it. Yeah,
There's
I don't know.
there are some patents that have been widely discussed from Intel that basically allow this, and a lot of people believe this is the next gen. We'll see. It won't come with Raptor.
All right, let's go back to our slides here. Here we go. All right, we're done with that one. Raptor Lake in the wild. Now, when Intel is doing product demonstrations and showing Raptor Lake systems running, like worst case, probably 6 months until launch, right?
About a little bit
And
longer,
and,
maybe.
and this was at their investor day, which how long ago was that, Paul?
Oh, you got me.
I don't
It's
I
not.
don't know
It's
either.
just
I was
a few
looking at
that.
it today, but I didn't check the date. Anyway, so this was their Raptor Lake system, and they showed it, cruising through some benchmarks and doing some cool stuff. We won't spend too much on that. Roadmap going forward. This is the key for Intel right here, and like we've written about this already in the past, but check this out. So right now they've got their Intel 7, which is formerly 10 nanometer, but 10 nanometer is a misnomer because, well, all of the process technologies are lies. They're just numbers that people pulled out of a hat. So that's shipping for Intel 4, which is supposed to be competitive with TSMC's 4 and 5 nanometer stuff. They're planning to have that manufacturing ready, like basically anytime in the next few months. Meteor Lake CPU tile, that's the next gen CPU after Raptor Lake, will be produced on Intel 4. Then we jump to Intel 3. They're hoping to have that manufactured ready in 2023 second half. Then you get your angstroms. So I guess an angstrom is like 0.1 nanometers. Is that right?
Yeah, it should be below a nanometer. It should be as you step
It's
down.
kind of weird to
Let's
me because I'm
not
like,
believe it.
why didn't we go to picometers? I guess they didn't want to say it's, well, 20 angstrom is 2 nanometers effectively is what they're saying.
Pretty much.
So they changed their numbering scheme again because they didn't want to jump back up and say, hey, we're at 2,000 picometers, and they didn't want to say 2 nanometers, so whatever. It gives them, we're back into the double digits so that they can reduce it down until we're in the like 5 angstrom range, I guess. So next 4 years, Intel wants to get 5 different nodes up and running. And then this is what they hope to do on the CPU side. We've got Alder Lakes out. Raptor Lake is coming soon. Meteor Lake and Arrow Lake. And then Lunar Lake and beyond.
Just interesting. One thing that's very interesting about Intel's messaging lately, and I have absolutely noticed this, is they are saying very little about Raptor Lake. Normally by now we're hearing all kinds of stuff about Raptor Lake, the next chip generation. I don't think it's because they're not proud of it. I think it's because it's an iteration. But even in the past, they've talked about more. What they're really talking about a lot is Meteor Lake. They're showing diagrams. They've shown pictures of they've shown the actual silicon multiple times now. There's even been, they've even shared a diagram of the architecture that's not, well, it's an actual die pick that, can be annotated by people who are good at those things. But it is absolutely surprising that they're talking more about Meteor Lake than they are Raptor.
It feels a bit like it feels a bit like when they did Broadwell for desktops and Skylake back in 2015. Like they really didn't. I don't know that you could say they didn't care, but they didn't care about Broadwell anymore. They were all eyes on the future of Skylake, and it was like Broadwell launched, and Skylake came 2 months later. It was so fast because Broadwell was delayed.
A fast follower and a much bigger jump in performance, like something that they're really wanting to hang their hat on. We'll see, but it definitely does feel like everything from Intel lately is Meteor Lake. If they're teasing it, it's Meteor Lake. They really have nothing much to say about Raptor Lake.
Question, just to reiterate this, RCALD. Intel 4 is equivalent to which nanometer in real, I'll put finger quotes, real lithography? Because there's no 4 nanometer or 7 nanometer or whatever features.
Correct. And the big thing is even the nanometer was always just a measure of gate length. And so it's like one dimension in a multiple dimension device. There's so many different things. And then as you move across a chip, they use different libraries, which have different densities across separate parts of the chip and different types of transistors. So it's always been just, even when there was a correlation, it's been a long time since any of it really made any sense. The main thing that you should look for is transistor density. And I have this written down somewhere, but the Intel 4, the density is, you'll have to give me a minute because I can assure you I don't know this type of stuff. I don't think very many people do off the top of their head.
And one of the things that, like, when we went to FinFET gates instead of the traditional gates, the planar gates or whatever they were, like, that was one of the things that made the numbers even less useful. Now we're going to gate all around. You know, the measurement of 4 nanometers or whatever you will, like, they're not measuring anything really. They're just using a smaller number because that's what people expect.
Yes, exactly.
But comparable, like Intel's not wrong when they say that their 10 nanometer, which they renamed to Intel 7, they're saying it's basically comparable to TSMC's 7 nanometer, Samsung's 7 nanometer, and they're not wrong. Like, there's differences, but they're not huge differences. And so Intel is pretty much saying our Intel 4 is going to be comparable to TSMC's 4 nanometer, 5 nanometer stuff.
So from a high level, when they create a very high level, when they create a process node like Intel 7 or Intel 4, they have 2 types within that. When you buy Intel 4, you create a chip with Intel 4, you're using either the high density library or you're using the high performance library. The high density library packs in more transistors into a smaller space so that you get the utmost of density. This is the number that they want to talk about in PR. So, and then the high density, or excuse me, the high density gives you a lot of density, more transistors in a small area. High performance gives you more performance, but you get fewer transistors in the same area. So you have 2 libraries. Intel with Intel 4 is only making the high performance version. They're not making the high density. They're just skipping it. They're saying, you know what? High density, schmensity. We're doing high performance. There are reasons about that. For that, I won't ramble. But the high performance has a density of 160 mega transistors per square millimeter. So the number to be that's relative here is 160. It will compete with TSMC 5 nanometer. TSMC 5 nanometers high performance is 130. So it's Intel's 160 versus TSMC's 130. Even TSMC's slower but denser product, the one that people don't talk about as much, is 167. So Intel 4 is 160, and it's high performance. It's something special. I think this is why it's going to be extremely competitive with TSMC 5 nanometer. There's an article on our site called Intel Debuts Meteor Lake and Intel 4 Node. If you Google that and check it out, there's a chart in there that kind of breaks it down. Intel 4 is going to be something else. It'll be really good. Competition.
I'm going to pull that up, drop the link, but give me a second. All right, let's go back to our... So this is what's coming. Walk us through this. This is Raptor Lake, the high-level overview. You want to read it, Paul? You want to take us through it?
Double-digit performance.
Meteor Lake.
Okay, yeah, Raptor Lake, double-digit performance boost. You know, this is marketing at its finest / worst, which is often the same thing. Don't pay any attention to that. We don't know what that means. Up to 24 cores and 32 threads. We knew that. 8 P cores that are threaded, and then 16 E cores, which only have one thread. Enhanced overclocking features, we believe, is a feature called enhanced thermal velocity boost. We'll see. The Raptor Lake is supposed to have a new type power delivery called DLVR that should enable a lot. I mean, it should give them a lot more power at lower. Everything about it is good. We have an article on that somewhere too. But I believe that the new overclocking feature will be tied to deliver DLVIR. Okay, and then AI M.2 module. Come on. They're going to make an M.2 module with a little ASIC or a little chip that does AI. I mean, whatever. I don't know. I mean, color me skeptical that that's anything more than a marketing bullet point. I don't
throw in some tensor cores.
Yeah, I don't see the practical application. If you're doing any type of AI that would require a separate processor, why in the world aren't you using your GPU?
Yeah.
If you're going to send it off, I would send it to the GPU. I don't understand why you would use a M.2. I mean, is there some use case where you're doing AI enhanced
your GPU
in the background while you're gaming, so your GPU is busy? I don't get it. It's a tough sell. I can't think
but I mean, you think about it, and it's like if you take NVIDIA's GPUs that have tensor cores, right? Yeah. Like when you look at how much die area is used for the tensor cores versus all the other stuff that a GPU does, it probably, like, they can probably save a lot by saying it's only AI, it's only tensor cores, it's nothing else. I mean, that's what Google does with their TPUs, and
specialized
multiple other companies are doing stuff like that. So, all right, socket compatible with Alder Lake systems. I think I forgot to include it. I had a slide or some data that you had pulled up that in the past that showed there are changes for chipsets coming. Like there will be new 700 series chipsets that will probably provide more lanes and all that stuff. But the socket will still be LGA 1700.
Yep.
All right. This is... Oh, wait. Did I put them in the wrong order? There we go. Meteor Lake. This is the exciting one.
About it. Yeah. Here I am ranting about Meteor Lake. Intel 4. This feels like this is what they're betting the farm on. This feels like this is what they want to do, the Conroe moment. When they drop the chip that just puts an end to the debate about whether or not they're better. I mean, Alder Lake is better than Zen 3, but
Zen 4
it's not like a Conroe difference where there's just it's not even a competition. I mean, it's close enough. If you push Zen 3 pricing down enough, it can compete with Alder Lake. But it's not that firm red underline, like there is no alternative, like Conroe. We refer to Conroe, which was the chip that gave Intel started its decade of dominance. When Conroe came, it was so much faster than AMD's chips that there really wasn't any conversation anymore about, oh, well, it's close enough if it's cheap. It was just that red underline, like, no, this is what you get. And that gave Intel a decade of dominance. They're not comparing Meteor to Conroe, and I have to be careful saying it, but that it feels like that's what they feel. But you can tell they're very excited about it for sure by the way they're talking about it. It's the big jump.
It's interesting because like Meteor Lake, we're getting a lot of these chips that are coming out next year probably from Intel and AMD and NVIDIA that are more and more talking about using, chip stacking of some form. We know AMD's talking GPU chiplets for RDNA 3. We still don't know exactly what they mean. And it's funny because there was some news this past week where someone was saying, video cards said that they're going to have a central GPU compute chiplet with multiple memory chiplets around it. And I'm like, I hope that's not what it is, because that just feels kind of like a letdown. I wanted to see multiple compute chiplets. Anyway, we don't know what everyone's doing exactly yet, but we do know that Meteor Lake is going to have a CPU tile, and then we've got a graphics tile, so they'll separate those out. Whether they'll be in package or stacked on each other is not entirely clear, but I think they're saying stacked, right, Paul?
They're saying Foveros, so that's 3D. When you look,
EMIB, right? Or are they doing EMIB, or are they just stacking?
No, EMIB is 2D.
Okay.
3D is Foveros, and what they do is they basically have what you could almost envision as a mesh that goes in between them, the base and the thing, and so it's like it's a 3D stacking with like little interposers, slices of silicon. It's very complex, and it has been very expensive technology. So, economy of scale. Maybe they've made some breakthroughs. They obviously must have. They have productized this with that one CPU that wasn't very impressive. I forget the name of it. It's in this laptop right here, though. Lakefield.
Lakefield.
Yeah. This is the 3D, but of course that's not the chip. But it's Lakefield, and that is a 3D chip. They've done it. And I don't know if you could say that's an HVM product, but which is high volume manufacturing. But this absolutely will be. So we'll see. I mean, they're going to use TSMC, presumably for the graphics tile.
Yeah, and this is interesting. So they say next gen graphics engine TGPU. I don't know what the T means.
What does that mean? I haven't thought that before. Tiled GPU.
Yeah. Oh yeah.
That'd be my guess.
So. I'm assuming when they say next-gen graphics engine, they're just saying next-gen relative to Alder Lake and Raptor Lake, which they're XE graphics, but they're not ARC XE graphics. They're not the newer XE. They're the first-gen XE. So this will probably be like the equivalent of integrated ARC graphics. It could be the next generation Battle Mage ARC, but I doubt it. I strongly doubt it. I think this will just be like, hey, instead of using XEDG1, we're going to use XEDG2, if you know those terms. Or, in other words, we're going from the integrated graphics that was part of Tiger Lake, their 10th gen mobile CPUs.
XELP.
XELP. And they're going to go from that to, it could be similar what do you call them, execution units or vector engine numbers, but the new ones will clock higher and be more performant overall. So
3 nanometer TSMC is the rumor. We'll see about that.
Yeah. So that's going to be exciting. That is coming in 2023, supposedly. So maybe in about a year. All right, last thing I just want to give the high level overview. This is all the crap that Intel is working on, and I don't mean crap in a bad way. I mean, like, they've got their fingers in a lot of pies. So we haven't talked a lot about these, but, at least on this show, but besides Alder Lake.
Is E-Core only. Sierra Forest is E-Core only in 2024. So they'll have Granite Rapids, which is standard P-cores, and then Sierra Forest, which is just all E-cores.
Yeah.
So that's
all right. So you can see here, we're already, Alder Lake's out. This slide was from a bit ago. Sapphire Rapids is now shipping. Is that right, Paul?
Oh,
I've been hearing about it for so long.
Yeah, the Intel breaks up its server chips into about 4 to 5 different levels because they ship them to hyperscalers, and they're early hyperscalers like Google or Facebook, the big guys, the Super 7 Plus, Super 7 Plus as they're called, is the name of those companies, and they'll ship them to them early. Yes, they've been shipping to them for quite a while, but they haven't done the actual retail launches where it goes to everybody. When they're shipping to the hyperscalers, the big behemoths, a lot of times that's not, I mean, it's production silicon, but it's not like production, put it in a retail box silicon, because that's why there's the distinction. They haven't had the official launch. They have continually put it off. You will see about 400 articles on Tom's Hardware about Intel announcements of delaying Sapphire Rapids. I can't even keep track of the delays. Last time I wrote about the last delay, I was just Googling Sapphire Rapids delay on our website to get the timeline back in my mind. And come on, guys.
It feels a little to me like Intel's ARC dedicated graphics. I laugh because it says Alchemist is shipping. I'm like, to China in limited volume. Ponte Vecchio is listed under first half of 22. First half 22 is over, and I'm
not
not
out,
sure that's really shipping.
And they're already talking about Rialto Bridge, which is the
Yeah.
second generation.
Yeah, so that's not even shown on here. Looking forward, like Alchemist, we've got a whole bunch of planned GPU products going down: Battle Mage, Celestial, and Druid. But Alchemist is still struggling to get out. We've been trying to get one of their A380 cards to test. It's coming from China through back channels and wending its way, and the others managed to apparently get them quicker. I'm not sure how, but it's been interesting seeing, like, it's clear that ARC's drivers aren't ready or weren't ready 2 or 3 months ago when they kind of soft launched it in China laptops. But they're getting better, and the latest is like, hey, if you've got an ARC GPU and you have an Intel platform with resizable bar support on the PCI Express lanes, that can help performance quite a bit, like 20 to 30% in some cases. I don't know how much of that is because rebar is so important, or if it's just that their drivers are so bad that rebar helps hide some of the driver problems. Anyway, once it launches in the US, I'm hoping we'll have better drivers, but we'll take a look at that as soon as we're able. Meteor Lake is coming next year, Arrow Lake after that, and even further out, we've got Lunar Lake. We only know the name of Lunar Lake, I think, at this point. So, yeah, Intel has a lot of things going on. They're trying to get back in the pole position, so to speak. Let's see.
I mean, they're giving it the old college try. It'll be interesting to see how it works out. Intel does have more of a challenge than pretty much any other chip maker in both manufacturing and designing its own chips. NVIDIA and AMD don't manufacture chips. They just design, and they turn a whole bucket loads of cash over to TSMC, and then do co-design and things with TSMC. But Intel goes it alone.
Which is why Intel is now doing their Intel Foundry stuff, trying to ramp that up. Like, yeah. That's a big part of Gelsinger's plan for Intel is, hey, we need to get other customers. I mean, it'd be really interesting if several years down the road we're seeing NVIDIA or AMD stuff made on an Intel Foundry. It's not out of the question. Right now it feels really weird, but at some point that could actually happen. In fact, there is a possibility that Intel splits off its foundry just like AMD did, except they would obviously still be at the high end, but it might help with their foundry business to be separate. That's speculation on Jared's part. You could call me an idiot if you want, but I don't think it's unheard of to consider that, just because how expensive foundries are becoming in terms of getting them built and keeping them occupied.
Yeah, the amount of money is insane.
Yeah. A comment here from Matt. So he says, yeah, Raptor Lake socket compatible. Sure, but socket 1700 is still a dead socket. That seems a bit much.
Well, here's the thing. That may or may not be true, because if you look at the cover on any socket 1700, it says socket 1700/1800. Because the socket 1700 is also socket 1800, which has never been used. They will add 100 more pins to create socket 1800, but they're physically identical. 1800 is supposed to be, I've got motherboards that say socket 1800, LGA 1700/1800 right on it. So, but they don't have the extra 100 pins, or if they do, it's not real clear if maybe those pins are there, they're just not used. The point is there's a ton of speculation. Raptor Lake is absolutely LGA 1700 because that's what Intel itself calls it. So they're not using the 1800 pins. Just like my camera's not focusing. But
yeah, you got to turn off Logitech's autofocus or whatever.
I know, man. But anyway, what's the point? The point is Meteor Lake may drop into 1700, but it
could just lose like 4
with
PCI Express lanes.
Correct. Yeah, you might just sacrifice something, and we've seen that all the time. You'll see the same thing with Raptor Lake. With Raptor Lake, if you put it in an older motherboard, you won't get as many PCIe 4.0 lanes because of the chipset. There's a lot of ways that this could play out. Intel hasn't said 1700s yet.
Yeah.
Until they say,
And
I mean, yes, it's logical to expect it to be, but at the same time, we'll see.
and here's my contrarian viewpoint. I don't know if it's even contrarian. I think a lot of people would agree with me. Like for all AMD's talk and certain people's talk about how great it was that socket AM4 stuck with us for so long. 300 series motherboards kind of sucked. The chipset kind of sucked. Supporting those was a drain on AMD. It was not helpful to AMD. Then you had their second generation 400 series chipsets. Those were like improved 300 series, but they didn't support PCI Express 4.0, and they still were more limited. Then we had their 500 series chipsets. I'm like, look, if you bought a Zen 3 CPU, like, I think, I wouldn't say you're stupid, but I'm like, I think you made a mistake if you didn't put it in a 500 series X570 board, or at least B550 board. I'm like, you missed out. So, there's something to be said for just saying, hey, you know what, we're going to do 2 generations on a socket, or at least officially support it, and then we're going to say, no, you should upgrade.
If you want to hear the real contrarian view, is Intel's answer to that. And Intel's answer is by sticking with the socket too long, you limit your connectivity options. And what happens is you're dropping new silicon into old capabilities. And they have a point.
Yeah.
There's both. There's pros and cons to each, but keeping the AM4 socket, when here we are talking, well, first of all, AMD fell behind on connectivity compared to Intel. They managed to have PCIe 4.0, but they can't go to DDR5. That's not going to happen. There are limitations there, and Intel has integrated tons of connectivity into their chipsets and into their sockets that AMD hasn't over the last few years. They've had the leading connectivity options for a while. Then additionally, when you look at AM4 with the Ryzen 5950X, we just talked about it in this show. It doesn't deliver enough power to power a 16-core chip. And AMD itself will tell you that. As a matter of fact,
Because
AMD,
it was a 5-year-old socket.
AMD itself says with AM5 we're going to 170 because we couldn't get. They tell you. You don't have to listen to me, but there's plenty of charts out there that'll show you on the power test that it physically can't deliver the power, and it doesn't matter if you uncork the power limits or what you do in your motherboard, and that's part of the reason why you can't overclock as high. They can't deliver the power, so you're dropping these very modern, sophisticated, wonderful chips into a limited socket. So there's both. There are 2 sides to this argument, and both of them have merit.
Yeah, I'm kind of that camp where I'm like, look, if I'm buying a new CPU for myself, like either I'm going to take my existing CPU and motherboard and case and everything and give it to someone, sell it to someone, give it to my wife or kids, whatever. I'm going to do something with it, and I'm going to put a new CPU and a new motherboard, even if I could have put it in my old motherboard, because I just don't like you said, I don't like sticking new CPU in an old motherboard. It just feels like a little bit, it's potentially limiting. You might only lose a few percent. You might only lose a bit of connectivity. People do both. And there are things like the 5800 X3D. Having all that L3 cache on it kind of makes the memory equation far less important on Ryzen. Like with that 3DV cache,
yeah,
like,
memory
hey, you could put it in a could put it in a 300 series chipset. You didn't get the PCI Express 4.0 lanes, but the memory speed and the bandwidth was no longer a concern. Anyway,
ECC memory. One thing is Intel is listening and learning. They do allow ECC memory with client chips now. It's probably not communicated enough,
and it's probably because of AMD being competitive.
It totally is. And LGA 1700/1800 might be the first time we see some of that impact on a socket. That's my instinct when I see this LGA 17 to 18 situation that hasn't been explained yet.
Yeah. All right. I think that's it. Anything else we got to say? Matt did say, yes, I understand. I mean, it's not the end of the world to be able to upgrade your CPU. My thing is just CPUs don't die very often.
They don't.
They
They're
do though.
wonderful.
They do die. Like, fun fact, my Ryzen 7 2700X system back in the day, because I tested PC Gamer, I was their CPU and GPU guy. It died out of the blue one day. Like, I was doing something and the system crashed and rebooted, and it never came back. And I was like, well, that was weird. I blamed the Gigabyte motherboard. Sorry, Gigabyte, but I sat there and fought with it for hours. And I was like, what is going on? So I finally like pulled out the motherboard, stuck in a different motherboard, and I got like 00 postcodes on the CPU. I'm like, this was literally just working and I wasn't doing anything to it. Still don't know what happened, but AMD had to send me a replacement. So CPUs can die, but
I've had
that's
memory
the
control.
only that's the only CPU I've personally had fail in the last 10 years where it literally went belly
The only
up and died.
CPU that I've had fail on me that I haven't killed. Now I've killed some of them, but I put my initials on it when I do. It's me doing it, right? It's me doing it. I'm burning my initials in with voltage. But the only ones I've ever seen is the only issues I've had is when the memory controller. I've had it happen on 2 chips, both an AMD and an Intel, to where the memory controller would no longer operate at the rated memory frequency. So DDR4 3200, the chip won't boot with it, but it'll do 2933.
I did that with the old socket AM2, like the second generation Athlon X2s. When I tested that for Anon Tech, I don't know what speed memory it was, but I was running it at the higher memory speeds, and 6 months after the reviews, I had a CPU that could no longer run anything. Like I had to run base frequency speeds on the memory, so you could burn them out. But that's we talked about this in a previous show. Like these smaller manufacturing processes, they don't do well. They don't scale well with analog interfaces, your external interfaces, and so memory interface is one of those. Maybe that's why AMD could put RDNA 3's
exactly
interface
what
on
I
the
was
chiplet.
thinking. That's exactly what I was thinking. It makes a lot of sense. Unfortunately,
yeah, we
Keep
shall
it on
see.
An older note. We will see.
Hopefully, we've got a major battle coming up in the next couple of months for both CPUs and GPUs, and it's going to be exciting. It's a great time to be an enthusiast, a PC enthusiast. Heck, it'll be a good time for laptops as well. We will be covering it when it happens. Anyway, thanks for joining us, and we'll see you next. Well, I will be gone next week. We'll see you in 2 weeks.
All right.